Yep. Next Tuesday, October 1st, exam based on chapter 3, 8, and 10. I already posted long time ago on Brightspace.
Yeah. So whatever it's
No, whatever we finish this week.
oh.
If we cannot finish everything, whatever we finish by Thursday, our exam will be based on that. So unfortunately, we cannot have a review before the exam because we didn't have a time. So instead of giving a quiz, I decided to just go over the rest of the materials. I knew you would be happy, guys. Okay, so we are still in 10.2. And when I see other people's how far they went with their materials in their classes, I realized I'm way behind with you guys. That's because I went very slow with the materials. So I have to pace up yourself. The review sheet is on Brightspace. Whatever we have the review sheet on next Tuesday, say next Thursday, I'll tell you up to where you will have your exam. So for now, we covered 3.6, 5.1, 8.1, 8.2, 10.2, and let's see how much you can finish this week. Roger.
I didn't see the YouTube video for this. I only saw like half classes. You like cut like half of what's in it.
Really?
Yeah, I didn't see that part of it. I only saw like half of it.
Oh, wow. Okay, I'll see what's wrong with the laptop video. Good news today with my evening class, afternoon class, I'll go over this material. So if I see that for some reason it wasn't recorded in our class, then you can just simply watch today's recording from my afternoon class. So anyway, now we know how to simplify numbers, how to simplify variables, and now you're going to multiply and then simplify. So when you multiply radicals, we do exactly the way we multiply non-radical things. So here we have only one term, and here we have two terms. So we are going to do distribution. So multiply square root of 6x times square root of 6. And then we have a minus. We multiply the other term, square root of 6x times square root of x. It's a distribution. But we get square root of 36x at 6x squared. As long as we have the same radical, we are allowed to multiply the inside, so we can multiply them because we have the same radical square root. So you're going to split that into two pieces, square root of 36 and square root of x. Same thing here. We're going to split into two pieces, square root of 6 and square root of x squared. Do we know what is square root of 36? 6. And square root of x, we have nothing to do. We cannot simplify. So we leave it alone. Same thing here, square root of 6, we cannot simplify. But what happens to the square root of x squared? Cancel out, so you're left with only x. And we cannot combine them. In order to combine radicals, we have to have the same inside. But we don't have the same inside. The first one has x inside the radical. The second one has 6 inside the radical. Department actually does something weird. You know, all these things I'm going over, I'm not supposed to go over with the materials with these. They said it's you're supposed to know them from before. So I'm still in section 10.2 because I'm actually covering so many sections in 12.2. So we go about everything in details in 10.23, but in 10.30, they assume you're smarter than everyone else. So you're supposed to know everything by heart. So in the final exam, even though these are not inside our syllabus, but in the final exam, that's this type of question. Whatever I did here, it's not in our syllabus, but in the final exam, we'll have this question. Same thing here. This is not inside our syllabus, but they give you this question. So many questions is not inside our syllabus, the section inside our syllabus, but they give questions from those sections. So this is one of them. It's not inside our syllabus, so you may not see any homework question on this, but in the final exam, we'll have a question like this. Okay, the next one, we have 2 terms by 2 terms. So we need to use FOIL. Oh, there is in the homework. There is? That's great. There are many things I'm covering here, which is not in the syllabus. Not 11 in 10. See, we're supposed to cover 10 point. I mean, last time? Last time in summer, are you talking about the summer? No, the last time. What was the last unit? So we're supposed to, in our syllabus, we have 10.2 and then 10.5. So we are missing 10.3 and 4. And I is 10.7. I is 10.7. So yeah, I'm covering all the chapter 10 here. That's why you're taking time. And that's why you're way behind than other instructors. But anyway, we'll finish everything. I'm preparing you for the final exam, okay? My goal is to give you all the materials which you're going to see in the final exam. Because passing the final exam is the hardest one. Okay, anyway. So when you multiply 2 term by 2 term, we use FOIL. So we take the first term and we multiply both terms on the second factor. So we have 4 square root of 2, 4 square root of 2. First term is 3 square root of 2. Second term is -4. Take one term from the first factor, multiply every term on the second factor. So our first term in the first factor is 4 square root of 2. We are multiplying 3 square root of 2. And then we have the minus in front of 4. So we have minus 4 square root of 2 times the 4. And now this is our second term in the first factor. So plus 7, we are going to multiply 3 square root of 2. And we have again negative and 7 and 4. 4 is a negative, that's why I put negative here. Okay. And 7 is a positive, so I don't have to worry about the sign. Bless you. And now the multiplication rule says when you multiply, we multiply the whole number with the whole number. And we multiply the inside number with the inside number, or if you have the same thing twice, just use the square power. So we have 4 times 3, which is 12, and we see the same square root of 2 twice. So either you can write square root of 4, or you can simply write square root of 2 with a 2 power, because we have the exact same thing twice. Minus. The next one doesn't have any square root. Only one of them has. So we just multiply the numbers with the numbers. We get 4 and a single square root of 2. Right, 4 times 4, 16. Thank you. I know, in the bus, I was sleeping, like it was so hard for me to keep my eyes open. That's because I couldn't sleep last night. Man, I hate this feeling. So the next one, we have the whole number 7 and 3, and there is only one square root. So I put 21 with the square root of 2. Finally, the last one, what do you get from the last one? 28 without any radical. So when you multiply radicals, the rule is multiply the coefficient with the coefficient and inside number with the inside number. And if you have the same thing, just use the square with the radical. Now the square root and square power, they cancel out, right? So we have 12 times 2. What is 12 times 2? 24. And what is happening here? We have negative 16 square root of 2 and positive 21 square root of 2. Can we combine them? We can, because they have the same radical with the same inside. When you add or subtract radical, the rule says if you have the same radical with the same inside, you can add or subtract their coefficients. So we have square root of 2 with the 16 and square root of 2 with the 21. That means, yep, we can combine this negative 16 with the positive 21. What do you get? Negative 16, positive 21? Positive 5, and then we keep our square root of 2. And we have our extra 28 alone. Do you see any like term anywhere? 24 and 28. So what is 24 minus 28? Negative 4, and we have 5 square root of 2. Or 5 square root of 2 minus 4. And I believe one of them will be in the final exam. Any question on this? Was any step unclear, confusing? So let me write down the rules what we applied here. Rules to multiply radicals. They must have same root. I.e. square root times square root. Square root times square root. They are the same square root, so we can multiply them. Or if you have cube root, you have to have cube root with another cube root. Then you can multiply them. Okay, so that's the rule. You have to have the same type of radical. If you have the same type of radical, then you multiply. Either if you have the same thing, you use the power, and if they're different thing, you just multiply the radical on the inside. Multiply their inside. Rules for addition and subtraction of radicals. they must have same root and same inside. So addition subtraction has two requirements. For example, square root of x plus 3 square root of x. We have the same radical with the inside, same radical with the same inside. If we have them, then add their coefficients. Coefficients means the number in the front. So we have the coefficient invisible 1, and we have the coefficient 3 here. So we add and we get 4 square root of x. For multiplication, only one requirement, same radical, then multiply the inside. For addition and subtraction, two requirements, same radical and the same inside. Then we add or subtract their coefficients. We'll leave the radical term alone. Okay, you try the next one. By the way, you definitely should work with your tutors. Okay. When you meet your tutors, you should go over the review sheet with them. Tutors with it, and tell them if they need the solution, it's on the video. Sometimes they do. Huh? Even though they're tutor, but they're still students. Okay. So sometimes they do. Do you know, is she teaching this semester or is she just tutoring this semester? Only tutoring? She also teaching classes? Taking classes. Yeah, she's very nice and very patient. I liked when last time she said, "Oh, you guys are not listening to her, so I'm gonna give you extra time to do all the work she's missing. It's like, oh, she's tough. Phew. Ready, guys? So this is our first term. We are going to multiply this and multiply that. Zachariah, what is your first step? What did you do? Mm-hmm. Mm-hmm. Don't forget about your sign. Times 2. And then this is our second term. So we are going to do the same thing. Let me change the color. Green. Jamil, what did you do? -3 times 2. So when you have plus sign, we ignore and we take the sign in front of the number. But since we have a minus in front of 3, we must keep the negative in front of 3. Jean, what did you do next? 20 radical 7 square, perfect. 10 radical 7 minus 6. Wonderful. Kevin.
So you simplify the radical 7 and the exponent 2.
Mhm.
And then you get 140. And you add 10 radical 7 minus 12 radical 7.
Can you combine them?
So -2 radical 7.
-2 radical 7, and this is extra.
640.
So now these are like terms. How much we have? 134 and 2 square root of 7. That's it. It's a step by step. Who is confused? Anybody? Pressure lane of 1. Okay, one more. You can try shortcut or you can try the way you did the last two. There is a shortcut for this one. Do you observe something? They are same, just their signs are different, right? Yeah. So we call them conjugates. Conjugates. Good job. When you multiply conjugates, it's the first term square minus second term square. So conjugate, when you multiply them, they gives us difference of perfect squares. Conjugate means the same two terms, but the middle signs are different. Ready? Daniela, what did you do? Square root of 13 times square root of 13. So plus square root of 13 times the negative 2. Plus 2 square root of 13. Plus 2 times negative 2.
Oh, okay. And then the square root of 13 is to the power 2.
Mm-hmm.
The square root of will be negative 2 times 2 is
Mm-hmm.
positive 2 times square root is
Mm-hmm.
plus 4.
Plus,
I mean, negative 4.
from here we get minus 4.
And then the square root of the power 2 we have 13. Or, yeah, like that's the negative 2 and we're doing the things to help us out.
And what is 13 minus 4? 9. So this is the details. But the shortcut says if you multiply the same things, just their signs are different, i.e., if you multiply to conjugates, we get the first term square minus the second term square. Always. So our first term is square root of 13. So we square the square root of 13. Our second term is 2. So we square the 2. And you always do minus. Always. So what is square root of 13 square? And what is 2 square? 4. So that gives us 9. See? It's only one line solution if you use shortcut. The 2-line solution. But if you don't know the shortcut, it's okay. Never mind. You can use the longer method. Okay, the next one. You can use a longer method or you can use the shortcut. Try the next one. We can use the shortcut because we have the same 2 first term. And we have the same second term. Since they're same, so they are conjugates. Five square root of 17 square minus 1 square. And here the exponent rules. We have 2 things inside, right? One is 5 and one is square root of 7. So don't forget, we must distribute the power to both of them. So you get 5 square and square root of 17 square. Minus what is 1 square? Okay, so the square root square cancel out. We get the 17. And from here we get 25. That means you have to multiply 25 times 17. 7 times 5 is 35. So we write 5 on the bottom. 3 goes on the top as an addition. And then we have 7 times 2 is 14, plus 3 is 15, 16, 17. Then you leave one space blank. And you do 1 times 25. So we have 5. 5 plus 2 is 2. We get 1, 2, 3, 4, 425. 425 minus 1 gives us 424. Yep, these are finalism questions. And you're going to do this without using calculator. In this exam, we don't need a calculator. This exam is non-calculator, everything. Calculator comes in chapter 10, no, not 10, 11, you'll need calculator. But for chapter 10, no calculator. Any question? Was any step unclear to anyone? Okay, so I'm going to skip many things because I'm preparing you for the exam. So this question, I'm not going to go over. This, no, and I'm moving to 10.5. 10.5 talks about rationalizing, especially rationalizing the denominator. So the purpose of rationalizing is sometimes we don't want something in some places. So if you don't want to see that in some places, get rid of that. The process of getting rid of something is called rationalizing. So in 10.5, our goal is to don't see any type of radical either on the top or on the bottom, somewhere. So if you want to get rid of the radical from the top, we call it rationalizing the numerator. But if you want to get rid of the radical from the denominator, we call it rationalizing the denominator. Okay, so do whatever you need to do, just get rid of the radical from the place you don't want to see. Why you do that? There are many reasons. Ignore all the details. Because sometimes radical gives us undefined solution. But if you get rid of the radical, the same concept gives us something valid. So that's why we rationalize things. That's the main purpose. Now I'm going to do easy ones first and then show you the harder ones. So first we are doing rationalizing the denominator. It means we don't want to see this thingy, the radical, on the denominator. So do something so the 2 stays, but the radical disappears. Bad news, we cannot simply square them. It's not possible. Okay. In order to apply square, we need to have equals something. But we don't have equals anything, just single square given to us. So what we do is we use a trick. We cannot simply square them, okay, no problem, but we can do something so that the result gives us the square automatically. So we cannot put this square directly. We need to use a trick. The trick is multiply with the same thing. So you have the same thing twice. You can cancel the power. Are you gonna like take off this? Exactly. Because I just skipped this part. I just put. And what did you put on the top? Without multiplying the radical 2? No, I'm talking about the bottom. Like, but did you multiply the numerator? Did you show the one from the numerator? Then it'll be fine. So the process is whatever we have, multiply by how many you need. So we have square root, means we want the same thing twice. So we multiply by 1. As a result, square root and the square power, they cancel out. So we have a denominator without any radical. The 2 stayed, but the radical disappeared. And remember, when you multiply, as long as we have the same type of radical, we keep the radical and you multiply the inside. So we get 3 times 2, square root of 6. And that's it. We can do the same thing if you want to rationalize the numerator. If you want to rationalize the numerator, it means we want to see the radical of the numerator. We want to see 3, but not that radical. And multiply top and bottom by what number that time? Radical 3. The next one is cube root of 7. So we want to keep our 7. But we don't want the cube root. So cube root means 3 times, right? So we are given only 1 time. How many more times we need to see the same thing? 2 more times, right? So this time we need to multiply cube root of 7 twice. Because the cube root means we want the same thing 3 times. As a result, we see the same thing 3 times. 1 time is given, we multiply extra 2 more times, total we have 3 times. So cube root, cube power cancel out. Now we have a 7 single. Actually, let me just keep going on. Yeah. So we have 7 on the denominator. And what do we have on the numerator? 7 cube root of what? We have 7 and 7, right? 49. So 7 cube root of 49. We are happy our denominator does not have any cube root. It has a 7 alone, a single 7. But then do you observe something?
It's 2, 7.
So what can we do?
You can go about cube root of 49.
Cube root of 49. Denominator got cancelled out, so you're nothing with the denominator, invisible 1. So depending on what type of radical given to us, we multiply the same thing, just 1 time less. Going in square root 2, so we need to multiply only once. Cube root, so we need to multiply twice. If you're given 4th root, how many more times you need to multiply? 3. So whatever radical we are given, we have to multiply 1 unit less. 5th root. So you can do a shortcut actually. You know that you need to multiply 4 times, right? Oh man, I hate that. Are you guys done with the left page?
Yeah.
Okay.
Answer to 2 times. There's no 2 and like put to the power 4.
Exactly, this is what you're going to do. So we had 2 5th root of 2. Instead of multiplying 5th root of 2 4 times, we can do 5th root of 2 4 times directly. Because we know we need total 5 times. So we need to multiply by 4 more of them. 5th root of 2, 4 times. So we have the same thing 5 times on the bottom. 5 root, 5 power cancel out. We get a 2 without any radical. What do you think we can do with this? What did you say?
Me? One of those sheets. Which by the top part, part by five. Five, I think.
No, on the top we multiply by 4 of them. So what you're gonna get? Remember the radical rule? Nth root of x to the m is same as nth root of x to the m. Do you remember the rule? Well, that means we can write 5th root of 2 to the 4 inside. Then multiply it 4 times. 5th root of 2 means 5th root of 2 to the 4th power means 5th root of 2, 5th root of 2, 5th root of 2, 5th root of 2, right? You have the same thing 4 times. Now multiply all of their inside. What do you get? So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. You get inside 16. Which we get the same thing here. 2 to the 4 is 16. So 5th root of 16. And just like the previous one, we have 2 on the top, 2 on the bottom. They get cancelled out. So answer is 5th root of 16. So you have 2 ways of doing it. Either apply the rule to make your life easier, but if you can't remember, multiply them individually 4 times. Any question? I have a good news and bad news at the same time. Good news, you'll not see this in the final exam. Bad news, you're going to see a harder one in the final exam.
And how is that a good? Right.
That's what I said. Good news and bad news.
Yeah.
So if you did not understand this, ask me now. I'll help you because the next one builds on this one. Okay? And also good news, I'm not going to ask this in this exam, but the harder one. So try one more and then we'll move on to the harder one. So this time we need to multiply by what? Square root of what? 2x. Because this is what we have on the denominator. So we have 11 square root of 2x. And what do you on the denominator? Only 2x. And that's it. It's only 2x because it's 2x square root. We have twice. And then the square root square power cancel out. Okay. Are you ready for the harder ones? It's not that hard. It just is FOIL instead of this. Ready? Okay. Let me know when you are ready.
I'm ready.
They're still copying. Skylar, Kaylin, are you guys ready? Okay. Now, all these examples we did, if you observe, we only one term in the denominator. So when you had one term, we multiplied by the denominator, or how many more we needed to multiply by. But now this time, we didn't have one term, we had two terms. This is one term, and this is another term. So when you have two terms, we cannot multiply top and bottom by whatever we did so far. For two terms, you need conjugate. Okay? For two terms on the denominator, we need conjugates. What is conjugate? Same thing, just the sign is opposite. So we are given 5 square root of 5 plus 1. We are going to multiply top and bottom by the conjugate of the denominator. So what will be the conjugate of the denominator? Square root of 5 minus 1. Square root of 5 minus 1. And you must put it inside a parenthesis. If you don't, then you'll mess up the multiplication. And then you just multiply. That's it. Usually for this, we don't multiply the numerator because our goal is to cancel at the end of the denominator if possible. So let me keep my numerator. If you multiply to conjugate, do you remember the example we did just a few minutes ago? When you multiply, Roger? Yep. We take the first term and second term and we squared them. First term squared, second term squared, and you always subtract them. That's why they called difference of perfect squares. So keep the top. We don't need to distribute. But what do you get on the denominator? 5 minus 1, which is simply 4. Sometimes when you simplify, you can actually cancel this with that. So that's why if you have a single number, don't distribute. But if you have two things, then distribute. You can, but many times, once you rationalize, you can actually cancel this with that. Here we cannot, but many times you can.
So leave it like that, or is it fine to simplify?
Leave it.
But it's still fine to simplify.
Okay, try the next one. And now you can actually simplify. You can cancel them. It is 9:24:24. Yeah, 9:24:24. Kaylin is here. Daniela is here. Alexis here. Sophia here. Evelyn here. Catherine Chen here. Sharon here. Kevin here. Emma here. Coran here. Kira here. Ibrahima here. Diani here. Alex here. Jonathan here. Shirley here. Shinea. Nicholas absent. Zachariah here. Jean here. Roger here. Catherine Lynn here. Jalen. Yariel here. Ashley here. Brenda finally came. Juliana sick. Vianney here. Niley here. Brittany absent. Aditya here. Jade here. Jamil here. Santiago here. Zayla absent. Skylar here. Singh here. 5 absent. Ready? Skylar. We need to multiply top and bottom by what? Good. 3 minus square root of 7. Kaylin, what do you do next? Since you have 2 singles, so actually let's keep our numerator. Tell me what to do on the denominator. Go ahead, Skylar. So we have 3 square root of 7, which is square. So let's keep our top. Jalen, what do you get on the denominator? Square root, square power, cancel out. We get 7. So we have 2, 3 minus square root of 7 over 2. Now do you see? What can you do with the 2 and 2? Cancelled out. That's what I said. If you have a single number, don't distribute. Because many times after the rationalization, we can actually cancel them. Okay? So in the final exam, you may see something like this. It's not hard, right? The thing is you have to figure out that you will multiply by conjugate and shortcut is their squares. Is there anybody who still needs help? Anybody needs help? No. Then let me skip the next one. All of them, rationalizing the numerator is the same thing. You just do multiply top and bottom by whatever you have on the numerator. And you're going to 10.6. 10.6 is radical equation. So instead of having a radical on the top or on the bottom, we have the radical equation, and our goal is to erase the radical from the equation. So do whatever steps necessary so that you can erase that thing. All the details you can skip. Let's do some example. Okay, let me tell you the rules. The rule is when we have radical with something extra, either in the front or on the side, that time radical is very strong. Okay, so we cannot touch the radical if it's strong. So our goal is to make it weak. So you get rid of everything we have next to the radical. Here we have plus 8, we need to get rid of that. Then we have minus in the front, get rid of that. So when we get rid of everything from next to the radical, now radical becomes very weak. So that time we can apply the square power to both sides and radical get disappeared. Cool, right? Not cool? It is actually cool. For example, when you're with your friends, you're stronger, right? In real life, when you're with friends, you're always stronger. But as soon as we get single out, we become very weak, don't we? In reality, we do. Most of us, when you're single, we are very weak. So our goal is to get rid of all the friends next to the radical, make it weak, and then we can put pressure on it, and the radical will disappear. So tell me the first step. What did you do?
I'm trying to get the radical by itself.
Right. The first problem is 8. Get rid of that. We subtract. So we have square root of 10x, the negative sign.
What's negative?
Negative 10.
And here, I would multiply both sides by -1.
Multiply by -1.
Then you would get square root of 20 equals 10.
10. And now it's weak, very weak. So what do you do? This time we can square both sides.
Then you would get 20x equals 10.
See, we put pressure on the top, putting a square. So it just broke down and we get 20x equals 100. Divide by 20. Divide by 20. So 20 cancel out. X is 5. So that's the process. Get rid of all the friends, make it single. When it's single, put pressure on it by applying the power. Then radical disappears. Solve for X. Okay? So this is easy when you have only one single thing on the other side of the equal sign. But it's not always true. Sometimes you get more than one term on the other side. That time you need to do the same stuff, but more things you have to do. So is our radical strong now or weak? Strong. It has a friend X next to that. So what is our first step? We want to get rid of the friend. So we add X. So we have 2X minus 1. The next side is negative 2 plus X. We can simply write X minus 2. So X is positive, 2 is negative. X minus 2. Uh-oh, now we have two things on the other side. But we're happy because friendless radical is very weak. So we put pressure on it. We put the power. So the radical and power cancel out. 2X minus 1. We are happy on the left side. But on the right side, we are not so happy. Really? There is no exponent rule of distribution if you have a negative or positive sign between the two terms. It cannot distribute the power. Not possible. Because there is a rule. All the rules are for multiplication and division. For addition and subtraction, there is no exponent rule. So what you do is you multiply your base twice. So X minus 2 times X minus 2. And now we are going to use distribution. We are going to multiply them. So what do you get? X times X is X squared. And then X times negative 2 is negative 2X. X times negative 2. You're going to distribute FOIL. Remember, 2 term by 2 term multiplication means FOIL. And then we take negative 2 times X. Negative 2X. And plus 4. So it's not X squared and 4. It's X squared minus 4X plus 4. See? That's why we don't like the right side. Because right side means more work. But the left side, we are happy. It's only 2X minus 1. But we have a new problem now. There are so many X's. One with the square power, one with single, there's another one single. So many X. Pressure. So plus. We can do that, but does it help us? We still have X on the left side, X on the right side. Yeah. Yeah, it is okay, but instead of taking the single one, you move everything to the one side. You have two sides and there are axes floating around everywhere. We don't like that. We want to bring everything to one side and then you're going to combine them. So bring everything to one side. So add one. Subtract the 2X, subtract 2X. They cancel out. What is left on the left side? Bring everything to one side. Our goal is to get everything to one side so that we can see 0 on one side. What do we have on the other side? X squared minus 6x plus 5. Oh, now it becomes a quadratic equation. Are you guys familiar with the quadratic equation? See, we skipped chapter 6, but chapter 6 talks about quadratic equation. So, department, assume you already have knowledge from chapter 6. Multiply to 5. Two numbers multiply to 5, add up to -6. What are the two numbers? Carol. 5 and what? 1 and 5. One of them has to be negative, right? Both of them have to be negative. So -1 times -5 gives you +5 when you multiply them. And -1 plus -5 gives you -6 when you add them. Two numbers multiplied is a constant combined to the middle term. What do we do with those? We put them into parentheses and you write those down. We are going to that. That's what I said. When you have two terms, small one. Our goal is to solve for x. What do you do? Each of them equals 0. That gives us x equals. Okay, we are happy. But we are not done. Exactly. Even roots are the most troublesome one. Since you're working with square roots, even roots, for every even root, we must check our solution. Because just because we got them, it doesn't mean they're correct. Okay? It's a silly thing. We got them, they're supposed to be correct, but actually no. Not always both of them work. So this time we should check. First, check this one. And when you check, we take the original one. Our original equation is 2x minus 1 minus x. The result has to be -2. Okay? So we found our x is 1. 2 times 1 minus 1, x is 1. 2 times 1 gives us 2 minus 1 minus 1. What is 2 minus 1? And what is square root of 1? Uh-oh, what is 1 minus 1? 0. But what number is supposed to get? -2. See how stupid that is? We got x equals to 1, but actually this doesn't work. So when we got a solution but it doesn't work, we call them extraneous solution. They have a special name. They're extra. They're extraneous solution. So these two are not same. So we cannot take x equals 1 as our solution. But we have to check. So 2x minus 1 minus x, the result should give us -2. And this time we have x is 5. So 2 times 5 minus 1 minus 5. What is 2 times 5 minus 1? 10 minus 1 gives us square root of 9. That gives us 3. And we are subtracting 5. What is 3 minus 5? -2. Oh, this time, do we have the same thing? Perfect. Same. So we are going to accept this as our solution. X equals 5. So only for even root, we're supposed to check that. For odd root, it doesn't matter. And you're going to see this in the final exam. These are final exam questions. So let's repeat the process again. What is our first step? What do you do? Make the radical weak, right? That is our goal. So do all the necessary steps, take all the necessary steps to make it alone. Once it's alone, it becomes weak. So we put pressure on it by putting a square. So square root, square power cancel out. We're happy with one side, but the other side, we have to use FOIL to distribute them. And then we bring everything to one side because our goal is to factor them. Once we factor, we set each factor equals 0, solve for x, and then we check. So these are the steps. Daniela, no phone. Try the next one. Are you done, Raja, or you're thinking? Which one? Okay. But no phone. How come you guys are quiet? Ashley, Vianney, Evelyn. Hired? Who? How about Evelyn? How come Sophia and Emma, you guys are single today? Did you guys have fight? No?
I'm asleep.
Ready? Oh. Brenda, first step. What is our first step? Emma.
When we get to the point and find like facts, how do we know which one is that?
The bigger factor always gets the middle sign. The bigger factor gets the middle sign. So whatever you have in the middle sign, the two factors you got, the bigger one must get that sign. And then we decide the sign for the smaller one. Then the bigger factor has to be positive. Ibrahima, what is your first step? Good. This time it doesn't have any friends. It's single. So we can square right away on the first step. So what is left? What do you get? From the left, we get 2x minus 3. And on the right, we are going to FOIL. Great. So what do you get from the FOIL? Plus 9. Great. And then? Six x plus 9, and we have 2x minus 3 on the other side. Aditya, what do you do next? No. Bring everything to one side. So how are you going to bring them? We subtract 2x, but what do we do with the minus 3? Add. So we subtract one of them, but add the other one. So what is left on the left side?
0.
0. And what do you on the right side? Plus 12. Emma, what two factors you got? Positive 2. So we have 6 times 2 gives us 12, and 6 and 2 gives us 8. But look what happens. If you have negative 6 plus 2, do you get negative 8? So the first one is always based on the middle sign. And the second one, we have to decide what is correct. If you do plus 2, we don't get negative 8. So it has to be minus 2. So first one is automatic given to us. But the second one, math. Do you see, Emma? Quran, what do you do next? Huh? So x minus 6, 0 gives us x equals 6. X minus 2, 0 gives us x is 2.
What do you do if you can't factor?
In this class, we will be able to factor.
9x and 12. When you do that?
In this class, you will be able to factor. So you have two things. Either you made a mistake, take your work, or when you're not in this class or probably pre-calculus or other math, then you're going to use quadratic formula.
Like the summer, got to do something else.
Quadratic formula. Roger?
When you say you pick factor out, they have to use quadratic. That's kind of hard.
Right. But in this class, whatever question you're going to get in the exam, either in class exam or final exam, all of them are factorable. So if it's not factorable, you find, that means something is wrong. But in the homework, if you cannot factor, no problem, it's quadratic formula. The life will be a little bit harder, but still we can find something. So are we done once we find the two solutions? No. We must check. And which equation do we use to check? The original one. I've seen many times people use this to check. Obviously, this is going to work because we factored from that. So don't ever use anything that doesn't have any square root. You must check the square root. Square root gives you the problem. So you have to start with the square root problem. 2x minus 3 should give you x minus 3. Since I'm going to check twice, I will write it twice. In the first one, my x is 6. Sophia, how do you check? So tell me what to write. Perfect. And then what do you get inside the radical? And then the other side? What is square root of 9? 3. So x equals 6 is correct. Kira, the next one. How are you going to check x equals 2? So tell me what to write. And then what do you have? And what is square root of 1? So is 1 same as -1? So this one doesn't work. So our only solution is x equals 6. See, that's why you must check, because not both of them going to work. And sometimes none of these work. When none of these work, we say the answer is no solution. No x value works for this equation. Any question? Okay, so I'm going to skip the rest from this section and move on to the next one. Done copying. Santiago, no phone. So I'm skipping all of these and going to 10.7. How did this happen? So 10.7 talks about complex numbers, means imaginary numbers. So when do we get complex numbers? When we have no real number that will satisfy the condition given to us. For example, if we have an equation x squared plus 1 equals 0, we know we're going to subtract 1 from both sides. And then we get x squared equals -1. We take the square root. But then square root means find same number, multiply twice, gives you the result -1. In real life, there is no number when you multiply the same thing twice turns into a negative. It's not possible. So this time we bump into a problem. We go away from the reality and we move on to a new world called imaginary world. In this imaginary world, the square root of -1 exists. We call it I. I means imaginary number. So square root of -1 is I. And now in this imaginary world, we call them all the numbers we have, we call them complex numbers. They are imaginary numbers, but they have a special name, complex number. We can write any imaginary number into two pieces. Square root of -a is same as you're multiplying -1 with the positive a. This -1 times positive a under the square root. Square root of a is a real portion, so we are going to get something from there. But square root of -1 is not real. So we get imaginary portion from there, which is I. Okay, that is some example. Square root of -16. Can you find two numbers when you multiply they become -16? Not possible. So because of this negative under the square root, we need to split that into two pieces. One is square root of -1, and then other one is our normal 16 positive. What is square root of -1? And do we know what is square root of 16? 4. Combining them, we get 4i. So this is the details. Once you have confidence about all the steps, you don't need to show the details. You can simply write 4i. Because even it's 4i, it's not possible. What do you think about the next one? What will be the answer for the next one? This negative is extra, right? It's outside of the radical. And from here, what do you get? 3i. So it's negative 3i. We get 3i. If you want to see the details, no problem. It's square root of 1 times square root of positive 9. This is imaginary, not real. And this is the real number 3. When you combine all of them together, we get the extra negative and then 3i. But not always we will be able to simplify our radical. Sometimes we cannot simplify. That time we keep our radical alone. So what do you think about C? If you split into 2 pieces, what do you get? And what is square root of -1? This time, do we know what is square root of 7? We don't, right? You see? We could not simplify square root of 7 here. So you left it alone. When it cannot simplify, we leave it alone. When it can simplify, we do simplify, like the Lec8. Try D by yourself. We are simplifying square root of -18. Done? What do you have?
Then you would have -1 AC for
Mm-hmm.
then -1 down y. And then for BC, 9 for 9 for 2.
Good.
Yep, for 9 3. Here 3.
So we have -3i square root of 2. Or -3 square root of 2 and then single I. My MATLAB wants you to write I in the front of the radical. But in real life, you can put the numbers together and then I perfect. Both formats are correct. Any questions so far? Okay, let's see what do you have next. Multiplying imaginary numbers. It's just like multiplying real numbers, but anytime you bump into 2 i's, it becomes I squared. And you have to remember that every I squared gives you the real number -1. Cool, right? If you have two i's together, it becomes real. So square root of, sorry, I square gives you -1, real number -1. But if we have the square root of -1 is a single I, but if you have I twice, it becomes the real number -1. Okay, what do you think? -3i times -9i. Negative times negative. Really? 3 times 9, 27. And how about I times I? I square. And what is I square? -1. So we have a 27 positive times -1. -27. So if you multiply two imaginary numbers, they become real. So if you have two imaginary friends, put them together, they will become reality. Like movies, children movies. They always talk to their imaginary friends, right? Think about the next one. Rationalizing, not fun. This is the reason why I forbid you from using the formula. Okay, then I'll give you harder ones. It's coming. If you're done with the left, no problem. We have the right one. Are you guys done with the left page? Yeah, okay. Then two of them. Try them. They did not give us I directly. That means you have to find the I first and then simplify. Alex, what did you do? Your first step. I knew it. Most of you are going to multiply -2 with -14. Most. I said most. See, it's wrong. You cannot multiply because it's not real number. For a real number, you can multiply the inside or you can divide the inside. So first you have to pull out your negative. So it becomes I square root of 2. This becomes I square root of 14. So i's and i's, you multiply them. See, that's why. So you have 2 and 14. They both are real because they don't have any negative. So square root of 28. 28. But we can simplify 28. 4 and 7. Square root of 4, square root of 7. What is square root of 4? So you have 2 times negative 1 times square root of 7. Negative 2 square root of 7. I bet, Alexis, you get the answer positive 2 square root of 7. Right? That's what I was saying. If you multiply the two inside, the answer will be positive. But in reality, answer is not positive. It's negative. But it's square root of 4. If you multiply it, what? All right, yeah. Okay. So for imaginary number, don't multiply the inside. First pull out the imaginary portion, and then you can multiply the inside. What do you think about the next one? Surprisingly, in division, since you're going to cancel, so we can actually cancel right away the negative and negative. But if we do follow the real step, it's I square root of 90 divided by I square root of 2. So they cancel out anyway. Square root of 90 over square root of 2. You can rationalize or remember the radical, the exponent rules. If you have two radicals, you can combine them into one radical. It's like the exponent rule. If you have x over y with the any power n, it's x to the n, y to the n. So we apply the reverse of that formula, the rule. We are given double radicals. We can combine them single. Can you divide 2 and 90? What is half of 90? 45. So we simply have square root of 45. Exactly. Square root of 9 and 5. So 3 square root of 5. Is there anybody who is confused? Anybody needs more help with the explanation? You don't? Okay, now complex numbers, there are two parts. One is real, one is imaginary. So we should write the real number first and then the imaginary portion. Let me skip all the details and work with complex numbers. So when we add or subtract complex numbers, we add the real with the real, and we add or subtract the imaginary portion with the imaginary portion. So here you're subtracting to complex number, just like the normal one. When you distribute, the negative inside will turn into a positive. 8 minus 9i minus 6 plus 5i. The complex number, they have a real number first, and then addition or subtraction, the imaginary number. Everything can be written as a complex number. Complex number, or the real number, it doesn't. And then you combine like terms. What like terms do you see here? What do you get from 8 minus 6? Anything else? Negative 9, positive 5i. And that's it. We added and subtracted two complex numbers. Here. Here. Aditya.
How you interpret the dictionary?
What do you mean? Oh, so when you subtract, anytime you subtract more than one thing, all the sign will change whatever you're subtracting. So we are subtracting 6 minus 5y. We're subtracting 6 minus 5y. That means the 6 becomes negative 6, and the minus 5i turns into positive 5i because you're subtracting. Anytime you subtract things, they change the sign. But if you add, they don't change sign. Only when you subtract, everything changes sign. We have a single number, and then we have a complex number. We still can combine them. One more. And then what do you have? Multiplying. Oh, multiplying, dividing, simplifying, 3 things left. Okay. You can combine I with the I and number with the number. You can take I as a variable X. Oh. So positive 6 minus 3 minus 7i, 6 minus 3 minus 7i. Use 6i, 6i, 7i. That gives you 15i, so 14i, it is 10. So 6 and fucking 20i. I think 100.
Oh, shit. What kind of sick are you?
Right.
That's all we're missing.
Yes. If we distribute the positive sign, no sign will change. So basically you have the same thing as the other one. Right, it doesn't change the sign. Okay, Evelyn, what did you do for the first one, the left one?
Oh.
You didn't do it? It's okay, I'll help you. What did you do the double negative? Good. So it becomes positive 6. And then since you're adding, the sign will not change, right? Uh-huh. -3. Because plus and minus will turn into minus anyway. Great. So what do you have now? Any like terms? See, you got it correct. Be confident. 3 minus 7i. You can distribute the positive sign, but basically it means you're not changing anything. You simply have -3 minus 7i. Pressure, would you like to try the next one? That turns into what? 6i. Okay. The next one we have 2 and square root of 2 times 7i. That gives us what? And this is easy, -10. I minus 10. But in order to write complex number, we're supposed to write the real number first and then the imaginary portion. So it's right, but we're supposed to write -10 first and then the 20i. Because this is the format of complex number. Real number plus the imaginary portion. This is with more details, but you can do it shortcut. Shortcut. We have square root of -36, 2 times square root of -49, minus square root of 100. From here, we know it gives us 6i. If you know already, you can simply write 6i. You bring down it 2. From here, we get 7i. And this gives us 10. So 6i, 14i, and 10, that gives us -10, +20i. Any question from anyone? So remember, your exam is 1 week from today, next week, Tuesday.
I'm gonna give her other. I don't think you can do them right.
Okay, see you all on Thursday.
Gonna add like bonus questions, like where it's at.
I'll think about it.
Just in case, 'cause I feel like I get talking about it.
I'll think about it. I have space.
Give us.
The quiz
Okay.
is next Tuesday, right?
Not quiz,
I mean,
exam.
yeah, exam.
Mhm.
And we have class on Thursday.
Mhm.
Are we gonna do
We are
it?
going to finish the lecture, the rest of the materials, and then we are going to do a review.
Okay. What else? How many questions?
I didn't make the exam yet.
Okay, so I'll ask you on Thursday. Okay, thank you. Have a good day.
Mhm.